Lenses. Objectives: to understand the formation of a convex and a concave lens, to understand how these lenses work. Convex lens. Arrange two prisms so that their rectangular rough surfaces are facing each other. The parallel rays incident on the prisms emerge on the other side after refraction and intersect at a point. Insert a few more slabs of prisms between the two prisms. The parallel rays incident on such an assembly will undergo maximum refraction at its top and bottom. The rays undergo no refraction at the center of the lens. Now, if we arrange two more prisms at the sides of this arrangement, then the incident rays emerging from them also converge at the same point. A single piece of glass formed in this fashion is called a convex lens. We can consider these equally curved surfaces of lens to be small parts of spheres. The center of these spheres is called the center of curvature of the lens. The radius of the spheres is known as the radius of curvature of the lens. The line joining the center of curvature on both the sides of the lens is known as the principal axis, which passes through the optical center of the lens. The light rays parallel to the principal axis and incident on one side of the lens undergo refraction and converge at a point on the principal axis on the other side. This point is called the focal point or focus of the lens. The distance from the optical center of the lens to the focal point is called the focal length of the lens. The focal length of the lens depends on its curvature. Take two lenses of the same diameter but of different thickness and hence curvature. When the parallel light rays are incident on them, you can observe that the light rays passing through the thick lens undergo more refraction and get converged at a shorter distance as compared to the thin lens, which causes less refraction. So we can observe that the thick lens has a shorter focal length than the thin lens. The image formed by the convex lens in this case is a real image of an object. The convex lens can focus the light from the sun to a point on the other side of the lens. The concentration of light energy at this point causes the paper to heat up and burn. The lens in a human eye is convex in nature. We should not look at the sun directly as it can damage our eyes permanently. Hence, we've understood that the rays of light incident on a convex lens get converged on the other side. So it can also be called a converging lens. Let us look at another kind of lens which diverges the light rays passing through it. Concave lens. Place two prisms with their vertices in contact and arrange a few slabs of rectangular prisms beside each of them. The parallel rays of light falling on such an arrangement refract away from the center. Overall, we can see that the light undergoes divergence and it emerges on the other side. A single piece of glass formed in this fashion having inward curvature is called the concave lens. The parallel rays of light incident on the concave lens undergo divergence as they emerge on the other side. If the divergent rays are extended backwards, then they appear to meet at one point on the principal axis, on the same side of the lens as the object. This point is called the focal point of the concave lens. The sun viewed from a concave lens would appear as a point. If you place a paper at this point, it would not get heated. The image formed in this case is a virtual image. The concave lenses are used to correct the short-sightedness in people suffering from myopia. A concave lens is also used in the peepholes of doors to get a minimized image of the person on the other side of the door. To summarize, we've understood that light rays parallel to the principal axis and incident on one side of the convex lens undergo refraction and converge at a point on the principal axis on the other side. The focal length of thinner lens is greater than that of the thicker lens. A real image produced by a convex lens is formed on the other side of the lens. The parallel rays of light incident on a concave lens undergo divergence as they emerge on the other side. The concave lens produces a virtual image, that is, an image formed on the same side of the lens as the object.